Hello, in this video, I'm going to talk about Phoenix tuners. What are they, how to use them, I'll try to explain the UI and give some more practical examples, so let's get started. So what are they? The Voxel and Particle Tuners in Chaos Phoenix allow you to modify the different channel values for each voxel based on certain conditions, and/or limit the effect of various forces to specific areas of the simulator where those conditions are met. That's all there is. All right, thanks for watching. Like and subscribe. See you next time. That was a joke, of course. But really, that's all they are. However, if you are just opening them for the first time, they can be a bit scary, confusing, and overwhelming. Trust me, I know the feeling. I got very excited about this new toy when they were first introduced. But later, when I finally got to try them, I was like, what the hell is all this? Turns out, they are pretty convenient, easy to use, and at the same time, super powerful tools. Let's look at them. There are two versions, a voxel tuner, the one with the little boxes on the icon, and the other one with the circles is called a particle tuner. They are pretty similar, they do the same thing. The UI is almost identical. The only difference is that the first one targets and modifies channels specific to the fire and smoke grid, and the other one targets the channels of the liquid simulation grid. If I select the voxel tuner and open this dropdown, I can see channels such as temperature, smoke, fuel, the speed channel, which tells us how fast the fluid is moving, the velocity channels X, Y, and Z, which tells us in which direction it is moving, and the red, green, and blue channels. The particle tuner, on the other hand, can modify things such as the size of the particles, the age, and the viscosity. Again, there are R, G, and B channels, as well as velocity and speed. The particle tuner can't create new particles. It only modifies the properties of the existing ones. But it can remove them, or delete them. Here on top, there's a field that specifies which particle types will be affected. By default, it affects only the liquid particles, but it can affect the other types as well, the splash, mist, and foam particles. And it can modify a few or all of them at once. It is very important to note that everything that you want to be affected by the tuners has to be marked for export inside the output rollout and written in the cache files of the simulation. So here's how they work. When the simulation is running and there's an active tuner present in your scene, on each simulation step, it looks at the content of each voxel and checks if the specified condition is true or false. Let's first look at the voxel tuner. By default, it checks if the temperature inside any of the voxels is above 800 Kelvin. The default temperature of the fire simulation grid is 300 Kelvin, which is the air temperature of a warm summer day, meaning that all of the voxels will be at this temperature value. 300 is less than 800, and the tuner won't modify anything. But if I introduce a fire source that, by default, emits a temperature of 2000 Kelvin on the surface of the sphere, for example, the tuner will check these voxels, the condition for it to trigger will be met, and it will perform whatever instructions are set in this area down here. In a way, we have a simple if-then statement. If this is true, do this. Increase the temperature inside these specific voxels by 1 Kelvin on each simulation step. And I keep saying on each simulation step because this is important. If you start the simulation at frame 0 and set it to run with 10 steps per frame, in this case, on frame 1, the temperature will be increased by 10 Kelvin, not just 1, as it is set here. Actually, that's not a great example, because in the case of temperature, it doesn't seem to rise, even though the tuner is supposed to increase it. The cooling parameter in the dynamic settings keeps pulling it down, and it looks like the two are balancing each other out. But if I set cooling to 0, the temperature starts rising by 10 Kelvin per frame, because of those 10 steps per frame. So, in other words, it's working exactly as it should. Okay? So you can increase the value, decrease it, or set it to a specific value immediately or with some delay. The delay is defined by the build-up time, and the value is in seconds. 1 means 1 second, which in my case is 25 frames. So right now the tuner is checking the temperature and it is modifying the temperature. But it can modify any of the other existing channels instead. For example, it can increase or decrease the speed, or the smoke amount, or the velocity on the z-axis, or the x-axis. Let's try that. If the temperature is above 800, then increase the x velocity by 1. Let's see what that'll do. Right, a value of just 1 might not be very noticeable. Let's try 200. Or perhaps 300. Yeah, you can see that inside the voxels, where the temperature is above 800 Kelvin, the velocity is modified to go in this direction. But up here, where the fluid isn't that hot, it doesn't have any effect. And by the way, if you want it to move in the opposite direction, you can use a negative value. This is because velocity, being a vector, can have negative values. And now, that value is increasing in a negative direction. But I can set it to decrease, and it'll start changing toward the positive values again. Right, that's all very nice. But it's not the most practical example, is it? So let me try something else. Let's, for example, select the source and disable the smoke emission. That way, the source won't emit any smoke directly. Right, so let's press Start. And yep, no smoke. The velocity is still being modified based on the temperature. Okay, select the tuner and set it to modify the smoke channel. I want to set the smoke to one inside the voxels that are hotter than 800 Kelvin, which would be down here near the source object. And, by mistake, I left the operation set to decrease. So I ended up with some negative values for the smoke, which doesn't really make much sense, right? But if I start increasing it instead, it quickly goes above 1, which is the typical smoke amount, right? There's quite a lot of smoke building up, which is why I prefer to use the set to operation in this case, and just set a target value of 1. Then set the time needed for it to reach that target. So this creates smoke in hot areas, without actually emitting it from the source. But again, not the most practical example. So let me just open this editor for a second. I'll explain everything about it in a few minutes, but for now I'll just try to modify the condition and see if I can force the smoke to appear only within a certain temperature range. Let's say those areas are where the temperature is less than 800 Kelvin. But let's see. Greater than, I don't know, 350? Slightly warmer than the environment. Okay. Less than 800, but greater than 350. Let's see. I was really hoping the smoke would appear here, on top of the flame, where the temperature is within that range. And it is working. That's what's happening. Unfortunately, down here on the surface of the flame, some voxels are also within the same temperature range. So I didn't quite achieve what I wanted. Instead, I just embarrassed myself in front of everyone. But anyway, I'm not going to re-record this part of the video because I believe mistakes are part of the process, and they can be a valuable learning experience, just like anything else. Okay, let's take a step back and talk about the editor window. Okay, so how do I change the condition? Unfortunately, I can't type directly into this field. I need to press the button over here, labeled Edit Condition, which opens the Edit Condition dialog. It looks suspiciously empty at first. It only shows this tree structure on the left. When I select the first line up here, I can see what this expression does. It checks if the temperature is greater than 800. If I collapse this, I can see it in the same format as it appears on the right-hand side. Okay, these two buttons are clickable. I can click on this one and it'll select the left part of the comparison. I can go up, select the right side, and go up again. With this dropdown, I can change the operation. Right now it's set to greater than. I can switch it to less than or equal to. Unfortunately, there's no less than or equal to or greater than or equal to. I'm not sure why that is, but I guess these three are enough. And there are a few other buttons I'll talk about in a minute. Let's look at what we have so far. This one, the left one, is set to a channel, and it's looking at the temperature. The other one is set to number, and that number is 800. These two entries have the same interface. But the important thing is which of these radio buttons is selected. With the first two radio buttons, we can select numerical values, either a specific number or a random number within a range. Then you have a channel. You can check the distance to a mesh. You can select an object from the scene. You can check the distance to a particle from a specific particle group, or check how many particles from that group are within a given radius. Finally, you can check the intensity values of a texture. And I totally understand how this might be confusing at first, because here, on the right side of that expression, where by default we have a numerical value, either a specific number or a random one, there's nothing stopping me from selecting a channel instead and choosing the temperature again. So now, I'm comparing the temperature to itself. And is this even possible? Well, why not? Let's check what this will do. Let's modify the smoke amount in case the comparison turns out to be true. I'll set it to 0. Let me just quickly double check if the smoke emission is enabled in the source. Yup, it's set to 1. So if this condition turns out to be true, I'll set the smoke to 0. Let me disable the GPU preview. And there's the smoke that's emitted by the source. So this comparison doesn't appear to give us a positive result. Is the temperature greater than itself? No, of course not. Is it less than itself? No, it's not. But is it equal to itself? Yeah, it is. Apparently, that's true for all voxels. So the smoke is reduced to 0 everywhere. And we can compare different channels. For example, I can check if the smoke amount is equal to the temperature. Or, actually, let's check if it's greater than. The smoke is typically in the range between 0 and 1, and the temperature values are between 300 and whatever the source is emitting, 2,000 at the moment. And let's try this with some velocity on the x-axis. I'll try increasing it by 300. Right, so it doesn't seem like the smoke amount is greater than the temperature value. However, if I apply the velocity modification to the voxels, where the smoke amount is less than the temperature value, this appears to be true for the entire grid. And just for a few frames, the velocity was increased to more than 4,000. Okay, what I wanted to demonstrate is that these aren't wrong conditions. In fact, I believe it might be impossible to create a comparison that's invalid or will result in an error. It's either true or it isn't. Even this is a totally valid case. You can even set the left part of the comparison to a numerical value. You can check if 1,000 is less than the temperature. Let's switch this back to set the smoke to 0 where this happens to be true. Let's see what we get now. Where is 1,000 less than the temperature? Well, definitely near the source. 1,000 is a smaller number than 2,000. So the smoke is reduced to 0 immediately after it's emitted. Let's switch things around to make this more obvious. Let's disable the smoke emission from the source. And set the smoke amount to 1 inside those same voxels. Right, so now, even though there's no smoke emission, the tuner creates smoke in the voxels, where 1,000 is a smaller number than the temperature value. Exactly the same thing as saying temperature is above 1,000. I really hope that makes sense and that I'm explaining it clearly. As always, if you find any part of my explanation confusing, feel free to leave a comment. Let's not waste any more time and see how we can add a second comparison. All right, if you select the root of the tree structure on the left, you'll see a few buttons. The one labeled New Comparison will reset the tuner to its default state. Then you've got these two, this and New Comparison, or New Comparison. These will keep what's currently selected and add a new comparison on top. Now you'll see a new route labeled and. And by the way, if you look over here in the Scene Explorer, you'll notice a bunch of hidden scene nodes. They don't have any tweakable options, but these are all components of the tuner. This is the AND logic. It's actually this one. Here's the first comparison, the second one, and then the left and right sides for both. They're created in the active layer. I'm not exactly sure why, but I like keeping tuners on a separate layer so I can collapse them when I don't need them. Anyway, they're not essential to the workflow, so try to ignore them. Okay, so now there's this new parent entry for both comparisons. If I select it, I'll see something similar to before. The first comparison, a drop-down, and the second one underneath. From the drop-down, I can switch the logic to AND or. And here, it's business as usual. I can select each line and tweak the settings individually. All right, now that I've got this set up, let me try something with it. In the second comparison, instead of using a channel, I'll choose Distance to Mesh. I'll pick the sphere. It's the only mesh in the scene, so let's use it. The numerical value will represent the distance. Now, this distance isn't in scene units like centimeters, or inches, or some other units. It's measured in number of voxels. Currently, it's how many voxels away from the object's surface. 50 might be a good value. I don't know. Let's see. If I change the comparison to less than, it'll affect the 50 voxels closest to the sphere. But actually, I want to target the area that's more than 50 voxels away, so I'll keep it at greater than. With the AND logic, both of these conditions need to be true for the tuner to take effect. Both. All right, let me disable the smoke emission from the source and see what happens. Great, the temperature is rising, and 50 voxels away from the sphere, smoke is created, but only in voxels that are warmer than 800 Kelvin. Maybe 50 is too much. Let's try 40. Or 35. I'll also raise the smoke amount to 1 for half a second. Now I'm getting the result I was after a moment ago. Smoke appears only here, at the top. It might look nicer if it happened more gradually, maybe with a delay of 2 seconds. With a 2-second delay, there's not enough time for the smoke to reach a value of 1 before the temperature drops below 800. So the process begins when the fluid is 35 voxels away from the sphere, but it needs 2 seconds to reach the target value. Before that happens, it's already too cold, and it no longer meets the tuner's conditions, so smoke emission stops. But with a buildup time of 0, the amount jumps to 1 immediately, creating this harsh edge. But here's another option. Instead of a fixed distance of 35, I can use a random number. Say, a range between 30 and 50. Before, we had a sharp transition. Now it's more dithered. Let me expand the range even more. Actually, you know what? I'll tweak the scene a bit so I can better show you the and or logic. I'll hide the source for now. And I'll create a second sphere. Okay, select the tuner again. I'll use distance to mesh for the first comparison, pick the first sphere, and say, if the distance is less than 10 voxels, and the distance to the second sphere is also less than 10. Then set the smoke amount to 1 with a short delay. All right, the source is hidden, so it won't emit anything. Let's hit start and see what happens. And nothing happens. Because both conditions need to be true for any voxel for the tuner to work. But if I switch this to or, then either one of these spheres will trigger it. So now, voxels near either of the spheres will trigger smoke. Now, there's some smoke around both spheres. But yeah, the smoke isn't moving, it's just sitting there. There's no wind or some other force to affect it. Let's try the same thing, but with temperature. Might be more interesting to look at. I'll set it to 2000, with a build-up time of 1 second. Now, the areas around the spheres should start heating up. Yep, that's exactly what's happening. Although, maybe I shouldn't have changed the build-up time. Let me bring it down a bit. Okay, perfect. So that's the OR logic, if voxels are near this sphere, or near that one. Now I'll switch it back to AND, so that both conditions are required. And yep, now only voxels within range of both spheres are affected. If I bring the spheres closer, more voxels will heat up. So, using logic expressions, you can define more complex rules. You can keep building on top of this. Let's try something else. I'll copy one of these spheres a few times. I want to keep everything that I have so far, but add another comparison. Again, I'll use distance to mesh. Say, if it is less than 15. And I can set one of the logics to OR. Bear with me, please. I'm trying to figure this out as I go. Okay, I think I got it. Now it's voxels that are close to the first and the second sphere, or the ones that are close to the third one. The rule for the third sphere works. If I bring the other two closer, it activates voxels near both. But the third sphere acts independently. Alternatively, I could leave all logic set to AND, so all three must be close together for something to happen. Yes. Now, if I switch this one to OR, there won't be any heat created between these two. But if the third sphere is near either one of them, this one or that one, the tuner will trigger. So it works where sphere 1 and 3 are close to each other, or sphere 2 and 3 are close to each other. I hope that makes sense. All right, moving on. As always, if you have any issues or questions, feel free to leave a comment. There aren't that many comments on my videos, so I'm able to read all of them. Now, if I want to reset everything and start fresh, I can press New Comparison. But how do I delete just one entry? Unfortunately, I can't. Or at least, I haven't found a way. However, I can keep just one entry and discard the rest by pressing the button that says replace the entire expression with this, meaning the one I have selected. Oh, and maybe you've noticed the right-click menu. It's contextual, so clicking on a line shows options specific to that line. If I click on a value expression, I get a bunch of math operations. Unfortunately, I can't copy and paste the value. I have to edit it manually. This is something that could be improved in the future, I guess. One other limitation, even though you can build complex rules, you can't perform multiple actions with a single tuner. In other words, you can't raise the temperature and increase the smoke amount at the same time with just one tuner. It would have been great if I could assign a list of actions. But for now, if I want to do that, I need to create a second tuner with the same set of rules, but a different task. For example, this one could set the smoke to one where the same conditions appear. Okay, I now added some smoke. Before, I just had some temperature. But with the second tuner enabled, there's smoke as well. All right, I mentioned math operations earlier. Let's take a quick look. It'll be brief because I'm terrible at math. Let me first delete the second tuner and keep it simple. All right, if I right-click a value expression, I can select operations like addition, multiplication, division, and so on. If I click on the multiply button, it creates a numerical value, 2, and another branch defining the operation that I selected. So multiplied by 2. Let me raise this. I'm not exactly sure what is happening. Instead of multiplying by a number, I could multiply by some channel value. Speed, for example. The speed is around 400, so I guess it gets multiplied by that. To be completely honest with you, I've never actually used these before. Yeah, I told you I'm bad at math. And right now I'm not entirely sure what's going on. Let me think for a second. I'm adding speed to distance, but the distance is 15. Maybe I should apply the math operation here? Okay, let me remove this. Right-click the math expression and choose replace it with distance to sphere. So that one was kept, but the rest was removed. Then right-click on the numerical value and divide the number by something like 2. Okay, now it looks like it's working. Or I could multiply it by 2. Ah, this makes more sense. Still, I've never really had a practical use for these, but it's nice that they're there. You've got addition, multiplication, subtraction, division, all that. And you can also use values from other channels instead of fixed numbers. All right, let's reset the tuner. Select the root, press New Comparison. I'll clean up the scene a bit. Unhide the source. Disable the temperature. And this time, I'll activate fuel emission. Now I'll go to the output rollout and enable fuel channel export. Let's move the sphere up. Press Start. Let me hide the GPU preview and enable the fuel voxel preview. I'm not seeing anything. Oh, it's the preview range. There we go. Now some fuel is ejected outward from the object's surface due to the surface force. It's moving away from the sphere. But if I want it to move down, I can either use wind or make it colder than the environment. It should be something below 300, maybe 200 Kelvin. 200 Kelvin is like a cold Arctic night. So yeah, really cold. And now it moves downward. Perfect. I'll select the grid again and expand the fuel rollout. Here I can enable burning, otherwise the fuel won't ignite. With burning enabled, I can set the ignition temperature. It's 600 by default. But nothing in the grid is anywhere near that. Sure, I can emit the fuel at a temperature above its ignition point, something like 700 Kelvin. Technically, now it emits fuel that is already burning, and the temperature keeps rising because of the energy that it produces. But if I want to release non-burning fuel, I have to set the temperature below the ignition point, and cooler than the surroundings if I want it to fall. Then I'll need a separate heat source to ignite it. I'll copy the object and the source. Add the object. And set it to emit some temperature that is high enough to ignite the fuel. Now there's some warm air rising up. Hopefully it's hot enough. Cool. Not cool, but great. The burning fuel generates some additional energy. It rises up, the temperature goes above 2000 Kelvin, and the heat propagates and expands. All this started when hot air mixed with the fuel. But what if I want ignition only when fuel touches the second sphere? I'll delete the second source, open the tuner, set it so that if fuel amount in a voxel is greater than 0, it increases the temperature. Let's try increasing it by 100 Kelvin. That's probably too much, but let's see. Yeah, it ignites almost immediately. So maybe increase the temp by only 5 Kelvin per step? Yeah, that's much better. It takes longer to ignite. Now I'll add another condition. Distance to the sphere must be less than 2 voxels. This time I'll set a target temperature. Sure, I can keep the increase by, but let's see what would happen if I set a target value of, what was it, 600? Yeah, let's try that. It's looking good. Let's see if it catches fire when it touches the sphere. Nope, it's not heating above 600. That's due to the cooling parameter, the same issue we had before. So, set it higher, maybe 610. Now it works. I'll restart. Okay, it's moving down and ignites right on the sphere's surface. You'll notice there's smoke too, but this time it's not from the tuner. It's from the burning fuel. There's the smoke amount parameter. The default is 1. And there's also a threshold. If I hover my mouse here, a tooltip pops up that says, higher values cause less of the burning fuel to produce smoke. I'll set the threshold to 0.5 and reduce the smoke amount. Less smoke leaves more room for oxygen. That'll make it burn more violently. Yeah, now it burns properly. I wanted to show you how to use the voxel tuner to heat up and ignite fuel. This is something I used in the Molotov explosion project. It's a 2-part video tutorial that I made a while ago. It's not on this channel, but you'll find it on Chaos TV. I'll leave a link in the description if you are interested in seeing it. Okay, that's very nice, but let's move on. There are a few other options that we need to cover. So we looked at the numerical value expressions, the channels, and the distance to mesh. And let's now look at the other ones. The distance to particle, particles in radius, and texture intensity. Let's try the first one. I'll select this line and say, replace everything but this one. The distance to particles. But let me clean up the scene a bit first. Give me just a second. I'll disable the burning, delete this sphere, move the other one down here, and set the source back to its defaults. Okay, let's see. On the left side of the expression, it says from, and then the list is empty. And here's the from list. There's nothing in it indeed. Here you can type the names of different particle groups. Since this is a fire and smoke simulation, the only particles that we might have are drag particles. Oh, by the way, I want to point something out. If you open the documentation for the Voxel tuner, somewhere down here, there's an example that lists foam and splash particles as well. But that example just tells us that if there's more than one, they need to be separated by a comma. But in this case, we can only have drag particles, so this isn't important at the moment. You can emit those particles from the source. Go in there and enable the drag particles checkbox. I believe the default is 100, but I experimented a bit with this a moment ago, so I left it to 1. 1 is okay. And for the particles, you can export their velocity, the IDs, the age, and the RGB channel. Let's export the age. We might use it for something later. So if the distance to a drag particle is greater than, maybe 3 voxels? Actually, set this to less than to target the 3 voxel areas around each particle. Set the temperature to something cold, colder than the surrounding air, something like 200 Kelvin. And, let's see what will happen. Okay, there are some drag particles created. Let me zoom in a bit. And maybe increase the preview size. Okay, so these red squares are the particles. They are in this group. And in this dropdown, you can also see the other groups, such as liquid, splashes, mist, foam. This could be extra confusing. The fire and liquid simulators used to be just one single grid in earlier versions of Phoenix. But at some point, they were split into 2 separate ones. So these could be leftovers from that time. Or perhaps they were left there intentionally because, in theory, you can load cache files created with the liquid grid into the fire grid. I don't know why you would want that, but if you do it for whatever reason, or by mistake, I don't know. I guess it's nice that you can control the preview. But this is just for the preview anyway, right? Okay, but these are the ones that we're interested in. The particles emitted from sphere 001. Perhaps I could change the color to make them more visible? That's not very... maybe yellow? Nah, leave them red. Okay, now these particles that are supposed to go up are actually falling down. They still follow the temperature, but there's a pocket of cold air surrounding each one, so they move down with it. And in the viewport, it looks like they are disappearing, but that is only because I have preview just a slice enabled. Let me turn it off. Okay, now we see all of it, and most of them are falling down. Some are still moving up because there's enough hot air to push them up, I suppose. If I disable the tuner, they'll just follow the temperature's movement. But with the tuner enabled, a pocket of cold air is created around them, which pushes them down. Yeah, down here it is more apparent. And there's this blinking every 5 frames because I've set the sim to export a backup frame every 5 frames. The backup frames contain more data than the original frames, so that they can serve as restore points. So most likely the speed is being exported, although I didn't check it. and the preview is set to show them brighter when they move faster. But anyway, the important thing is that they create cold air around them and they fall down. But that's just an example of one of the crazy things you can do using a tuner. Let's do something that makes a bit more sense. Maybe disable the smoke emission in the source. And let's say, in these same areas, the 3 voxel radius around each drag particle, instead of cold air, maybe we can create some smoke? Let's increase it by 0.1. But since I won't use the set to a target value, let's add another comparison to act as a threshold instead. If the smoke amount is less than 1. Okay? So if the smoke's density isn't 1 already, increase it, but only around the particles. Okay, let's see. Show the smoke preview. Looks like there's still a lot of smoke produced from the beginning. But since I exported the age of the particles, maybe I can use that to force the smoke generation only around particles that are older. Let's try that with another comparison. Say, if the age... Yeah, there's no age in the voxel tuner. And this gives me an interesting idea. Let me quickly try something that I've never done before. Let me create a particle tuner. Open the editor. By default, it is set to look at the age channel. And if it is greater than 1, then maybe I can set one of the RGB channels to 1. Perhaps I could use this as a trigger for creating smoke. Just to make sure that the grid RGB is marked for export. It is. Okay, let's see what we have. The RGB preview is enabled, but it doesn't seem to have any effect. Probably because the particle tuner is set to affect liquid particles, which we don't have. Maybe I can use these, particles of sphere 001? Perhaps if I type this here, particles of sphere 001. Did I type this correctly? If this works, honestly, I'll bite my ass. I'll go and buy a lottery ticket or something. Nothing happens. And the RGB channel doesn't receive any info. To be honest, this thing over here looks weird as shit. Maybe it should be just the... Oh my god, yeah, these are drag particles. What was I thinking? Stupid me. Still nothing, though. Maybe if the age is greater than 0? Okay, what I think is happening is that the tuner sets the RGB channel of the particles, but not of the voxels. And I don't think we can use that as a trigger inside the voxel tuner, so yeah. This turned out to be a dumb idea after all. It was a nice experiment, though, so I might keep this in the video. Okay, anyway, let's think of another way to achieve what we want. Let's see. Since I can't use the age here, perhaps I can use the old trick with distance to a mesh. When the distance is greater than 30 voxels, and the other two are also true, begin increasing the smoke. These black voxels down here are the temperature channel. Let me hide it and look at just the smoke. Let's make it a bit brighter. Okay, it looks like it's working now. But they are too many, I think. Let me decrease the count. 0.01. Okay, so here's one. When it moves 30 voxels away from the sphere, some smoke is created around it. Okay, so they clump together at the top. Although there's an age channel exported, there's no lifespan that can be defined that deletes them after a while. The voxel tuner can't delete them either. So let me try the particle tuner one more time. This really bothers me. There's no reason why it shouldn't work. So drag particles. If the age is greater than 1, delete them. And do not modify anything else. And the value of 1 should be in seconds. Let's try 0.2. That's 5 frames. And they're gone. Huh, how cool is that? Yeah? Okay, a lifespan of 5 frames might be too short. Maybe change it back to 1 second. So, turns out that using a particle tuner with a fire and smoke simulation isn't such a bad idea after all. Gosh, I feel so smart right now. Really, I never thought of this before. All right, sorry about that. Let's move on and look at the other options. Delete this one. I'll select the root for the voxel tuners expression. Press the new comparison button to reset it. We just looked at this one. Let's now look at the particles and radius option. This field over here is the particle count. How many of them are found in a given area? Let's set it to 3 and specify the types of particles it will be searching for. At a distance that is less than... Let's try 5 voxels. It still says that the list is empty. Didn't I just type this in here? Anyway, so if there are 3 drag particles at a distance smaller than 5 voxels from each other, then do whatever you're doing. Increase the smoke, or whatever. And since I'm increasing it, I'll once again set a threshold using a second comparison. Maybe you've guessed it already. I do this all the time. Both of these need to be true. Okay, let's check it out. And something went wrong. Is it because there were no particles at the beginning? That's weird. Perhaps I did something wrong? It should be more than 3 particles in a 5 voxel radius, not less than. So it could be equal to 3 or greater than 3. Okay, when more than 3 particles clump together, they should trigger the tuner. There are 3 over here. Let's wait for a 4th one to join them, so they are more than 3. Right, they might be far from each other still. Let me rotate the view. Yeah. Perhaps I can increase the search radius. It's this value, the search radius. Maybe set it to 10. And if this doesn't work, I might just try to emit more particles. Let me first try to reduce the number of neighbors that each particle is searching for. Is the smoke preview enabled? Yes, it is. Okay, fine, I'll just emit more particles. Something happens right here. Here as well. I'll make the grid narrower and try to force them to clump together even more. All of the walls are jammed, so they shouldn't leave the grid. Okay, this looks more like it. Again, that's the expression. When these conditions appear, the tuner triggers and performs whatever instructions are set in here. Anyway, these two options make much more sense and will be more useful when we look at the particle tuner with a liquid simulation setup. Okay, the last option is the texture intensity. Let's reset the tuner once again. Select texture intensity. The texture goes into this slot. The values are typically between 0 and 1. 0 is black and 1 is white. So let's test for a middle gray value, 0.5. Okay, so now on the left side, it says that I didn't plug in any texture yet. The texture needs to be a 3D texture, something that can be mapped across the entire volume of the grid. A simple noise map will do just fine. It ranges between black and white, 0 and 1. And there are some middle gray values, above which the tuner should be activated. Oh my god, the Max UI is doing weird things again. Anyway, map 1. Okay, let's try this. Great. Though, the smoke amount is increased above 1, so it is outside the range of what we're seeing in the preview, and it got clipped. It didn't adapt, since I have the auto range option disabled. But there you go. I didn't define a threshold comparison, so the smoke got very dense very quickly. So I'll set it to 1 with a buildup of 5 frames. You can do this one way or the other. It's up to you. Of course, you can change the size of the noise. Or use a fractal pattern. And right now, the smoke is created across the entire grid. But I think that you already know what I'll do next. I'll add another condition. Say yes. I want the smoke to be produced where the texture is brighter than a middle gray value, but also only in areas where the temperature is above 1500. So the smoke is created only around the sphere, but at the same time, it is masked by the noise texture. So there are some spots that don't produce smoke, and I guess this may be used to add some details to it, some variations. All right, everyone, I know this ending felt a bit sudden, but this video is already closing in on 1 hour long, so I have to split it into 2 parts. In part 2, we'll explore the particle tuner. This one will be much shorter since we've already covered the UI and core concepts. In the second part, I'll walk you through some example scenes and share more tips and tricks. Part 2 is coming very soon, so if you haven't already, hit subscribe and ring the bell to get notified. Thanks again for watching. Drop any questions, suggestions, or critiques in the comments below. As always, take care, and I'll see you in the next one.